we're going to have a discussion now about engineering and the climate crisis. A few years ago, I heard the expression Goddhart's Law, and that's the principle that if a measure becomes a target, it ceases to be a good measure. And personally, I worry about that and the climate crisis. You know, as engineers, we tend to always look for what we can quantify. It would be no good if we managed to work out how to stop the temperature rising, for example, by putting dust into the atmosphere, if that still changed the climate in ways that weren't good or useful. So I do think, you know, and I think we all believe that engineering has a lot to do or to contribute to the struggle against the climate crisis. But we also need, I think, to talk to and listen to and debate with people who thought deeply about what addressing the climate crisis might mean. But first up, we're indeed very excited to have John Sauven, the CEO of Greenpeace. John.
Great, thank you, Connor, and it's great to be with you, and thank you all very much. So look, I'm just by way of a few words of introduction to this topic, which I think is incredibly important, and I just wanted to start setting a little bit of context, I suppose, to this discussion about climate change and to what extent we can techno-fix our way out of it. And I suppose one of the issues is just looking at it from, say, the start of the Industrial Revolution to where we are today. It is, relatively speaking, a linear line that we can draw, and a lot of people would say this was a linear line just showing increasing progress as our quality of life has just got better and better over the centuries. And I think that maybe up until the 1950s, if you weren't, for example, a whale, you could broadly view that as being true, not for everybody everywhere, of course, but broadly speaking, we were on a sort of trajectory where you could see human progress in terms of health and life expectancy and so on and so forth. I think that when we got to the 1950s, I think what they termed the Great Acceleration, when sort of consumption took off in quite unsustainable ways, I think you can begin to see that there was the beginning of a real challenge that we were facing in terms of operating within a safe operating space in terms of environmental boundaries. And I think that this is something which is people have become increasingly conscious about, not just in terms of climate change, but also in terms of the extinction crisis that we face. But I think also, and I think this also in the context of COVID, is that people are beginning to also understand that progress has come with it. With progress has come a number of, I would say, threats. Some of them could be viewed as catastrophic threats for the future of our existence, certainly in terms of a healthy existence, or one where we would view progress as a positive thing going forward, of which climate change is one, biodiversity loss is another. I think you can add to that things like nuclear and biological weapons. I think you could also add to that things like artificial intelligence. And I think all of these things in the round are making the world that we live in and for our own existence increasingly fragile and under threat. And I think that the issue around technology is and can we is there a technological fix to this, I suppose does pose the question, well, to a certain extent, is technology making this situation worse? And I think if you, for example, look at COVID-19 and the rise of zoonotic diseases and the threats that those zoonotic diseases pose to us going forward, a lot of that has come about partly because of what we would call technological progress, the destruction of nature, industrial agriculture, the industrial meat system, all of the things that have given us cheap food, cheap meat, of course, have got massive downsides to them in the fact that they're undermining the health of the system. And I think that we're also, I suppose, beginning to realize that, we are just but one species out of many millions of species. and we are disposing rather rapidly of all the other species, particularly wild species that we share this planet with. So in fact, I think it is 96% of, well, 4% of mammals are wild. And if you look at birds, I think 70% of birds are poultry. So, you know, you can see how dominant that we are becoming, and the livestock that are feeding us are becoming on this planet. And so when you look at the techno fix, or can engineering help us? Of course, to a certain extent, engineering can help us. I mean, it can provide us with renewable energy. It can provide us with low carbon forms of mobility. I think theoretically, it could also provide us with some of the food that we want. You know, even meat, for example, could come from cell cultures, and maybe even some of the commodities like palm oil, which are, you know, devastating the forests of Southeast Asia, could be made in vats to avoid the necessity of doing that. So, you know, I'm not saying that theoretically there isn't a technical fix to this in terms of, you know, people's standard of living, and in terms of at the same time taking our foot off the destruction of the natural world. But of course, there is also a different way of looking at this, and in terms of looking at this in a much more holistic way, in terms of how we view ourselves in relation to other species and in relation to nature, and how actually we want to live alongside nature and be part of nature. And I think one of the great debates in agriculture, which is going on at the moment, for example, is between about land, you know, is do you farm the land in such a way that biodiversity can thrive alongside the land that you are farming for food? Or is it the case that you set aside some wild reserves for nature and you just pour, you know, chemical inputs, pesticides and so on onto the rest of the land in order to grow food in huge industrial monocultures? And of course, this then brings back to the question of, like, we as a species, how we want to kind of live and what our relationship is to the natural world. Because, you know, I can technically fix the diet, or I can change my diet. So I could have a more plant-based diet that meant that vast tracts of land around the world could be given back to nature to store carbon, to restore biodiversity, and so on and so forth. But I personally would have to make a decision to change my diet in order to do that. I could then live comfortably in a natural world and have a very comfortable and healthy diet. But the alternative is I could also maybe achieve the same thing through engineering or geoengineering, in the sense I could create that food in a laboratory and also give that land back to nature and take my foot off the pedal of destruction, and have a different view of how I might solve these problems. Now, of course, this brings us to some quite difficult questions, because I would prefer actually we lived in balance with nature and we lived off the land in a more sustainable way. But I also realize that there are 8 going on 10 billion people in this world, that we have very powerful forces in the sense of corporations and governments that are deciding a lot of what is happening. And that the idea of, you know, 8 billion people individually making a choice to do something different, one, it's not necessarily in their power or ability to do that, maybe not even within their resources to be able to do that. So the system itself tends towards this idea of there being a techno fix, because that is in the interests of big corporations and powerful governments that want to control the system, the means of production, you know, the wealth creation, you know, for the owners of that means of production, and so on and so forth. So to what extent we have the ability to change that is, I think, something that we could discuss. But I'm also concerned about the fact that we don't have any time, and that to a certain extent a technical fix is in a way a much easier and more appealing in many ways if it could be done. I mean, just as an example, if you move from coal power to renewable energy power, for the people who are getting that power, say in their homes, all they have to do is flick a switch, and they don't have to change their behavior at all, really, in terms of getting, say, a light switched on. They just press the same switch and it happens. But of course, that's easy. The easy end of it, in a way, is to do with power. Even to deal with mobility is a relatively easy end of that system in terms of switching from the internal combustion engine, say, to electric vehicles. But the more challenging end of that, I think, is where we're posed with much more difficulties, and that definitely is in the area of our food and agriculture system. And I think in the UK, particularly, it's in the area, for example, of we live in 20 million buildings are energy inefficient. Is that how you make all those buildings energy efficient and not rely on fossil fuels for heating, for cooling? Cooking's easy, you can get electric cookers, but certainly for heating and cooling, all of these things are much more challenging, much more expensive, because this is not a light switch solution. It's not even a switch of mobility solution. It's actually going into 20 million homes and doing a massive, very large scale refurbishment of their homes. So I think that there are some really difficult engineering problems which we definitely do need solutions to, and where I think not enough effort actually goes into the areas where we particularly need solutions, while at the same time rethinking our relationship to the natural world and who we are as a species within that. Thank you.
Thank you very much, John. That perfectly phrases the sort of dilemmas that I was hoping we'd be able to discuss. Next up, another panel member is Rachel Lunnon?
Lunnon, yes.
Lunnon. Rachel was until recently a mathematician and programmer, but she left to become an activist with Extinction Rebellion and with Burning Pink. So, Rachel.
Yeah, so I want to agree with a huge amount of what John's just said. And I'm going to, at the danger of repeating some of it, perhaps slightly rephrase or emphasize and re-say some of it. So to start, my initial reaction to getting the question, the climate crisis, is engineering enough, was this is the wrong question. Climate change is simply a symptom of the way that we're living at the moment, where we're consuming resources at a huge rate, and then we get loads of waste that we try and throw away somewhere invisible, that carbon dioxide and all kinds of other horrible things. And we need to look at things in a more holistic way. So, as an example, the huge biodiversity loss that's happening, although climate change is driving some biodiversity loss, it's mainly other human activities at the moment that are doing that. So we should be thinking about the climate and ecological emergency all the time, rather than just the climate crisis, because if you start trying to deal with one aspect individually, then you might come up with a technological solution that does great environmental damage. So the next thing that I sort of want to stress here is that we can all see that engineering is needed to solve some of the really big problems that we've got. But before we can start to use those engineering things to solve the problems that we've got to have big changes in society. We've got to move away from this model of consumption to a model where we're actually considering ourselves to be part of nature, and part of which obviously we are part of nature, so that we're using resources in a sensible way, so that we're reusing things and considering ourselves to be part of a cycle rather than polluting things massively. And I think the question for me is, though, how do we move so that society is ready to make those changes that we need to make? Well, we essentially need a wartime effort so that every aspect, more or less every aspect of our lives is dedicated to sorting this problem out, or at least much more so than it is at the moment. And COVID gives us a very good example of what it feels like to be living through an emergency. But we need to sort of have a bigger effort than that for the climate crisis. And I think it's also important to understand things like Jevon's paradox, for example, where with engineering, you add in efficiencies to systems, those greater efficiencies tend to lead to much greater resource consumption. So that's the natural way that things work. And you have to have things in place within our society, I think, before you start adding in your engineering solutions. Because if at the moment we just add in huge carbon capture to pull out carbon dioxide from the atmosphere, it's going to lead to people saying, oh, well, we can relax a bit and we don't need to worry so much about all the fossil fuels that are being burned. So in terms of moving society over to the place that it needs to be so that we can make the radical change, so that we're all living with this sort of huge wartime effort, this is actually some kind of, it's basically a civil rights issue for our future selves. And those kinds of rights are won by taking action, but by taking direct action and disrupting the system and demanding the change, because the system by itself doesn't want to change. The system is attuned to capitalists making money. So what I'm sitting here saying is we need to have radical truth telling from all sectors of society, including the engineers. We need to have things like look up Scientist Rebellion on the web to do direct action, civil disobedience. Look up flat pack democracies of ways of trying to get participatory democracy to happen. And I think we need to do that kind of thing to move society so that we can make the changes needed. Thank you.
That was very powerful. Thank you very much. Just to remind people, put any comments you have in the Q&A. When all the panel speakers have introduced themselves, we'll have a general discussion. We'll address the questions that you put into Q&A, and also if you put your hand up, we can unmute you and you can talk directly, whichever you prefer. So next up is an engineer, our own Chris Preist, and I imagine he's going to tell us the truth as suggested by Rachel. So, Chris. Chris, we can't hear you if you are talking.
I know, I lost the mute button by sharing. So let me just go back. Okay, so what I'd like to do is actually give you a kind of case study to talk about one of the examples in some ways of what John and Rachel have already spoken about. So as many of you know, I'm a computer scientist. I worked for many years with Hewlett-Packard Research Labs. And while I was at Hewlett-Packard Research Labs, there was increasing interest among senior management in climate change, brought about partly by Al Gore's film. And this is a cautionary tale about engagement with that message. So the senior managers, they wanted to both do good, and they also wanted to, if you like, kind of reduce risk of legislation coming in their direction. So they wanted to argue that digital technology is good for reducing emissions. And here is a diagram from a report they produced. And I want you to particularly look at, this is basically saying that, okay, so digital technology uses electricity, uses resources, but it can save far more emissions than what it uses. And this is the diagram that they used as part of that report. And I want to look particularly at the mobility one, which is the first of those. So technology can reduce emissions. This is true. And if we take mobility as an example, we can see that during the COVID crisis, effectively what's happened is that many of us are doing what we are doing today. We are using digital technology to allow us to remote work and communicate with each other. And that has genuinely reduced emissions on the road. There are less cars on the road. And so it can be used when there are constraints on society. It can be used to reduce emissions. But there are unintended consequences of this. And it's been noted that the increase in home working has allowed people to live further away from home. And that's something that's been quantified in the USA. On average, people now live further away. They live further away from work than they used to. And the most extreme example of that I can give is actually a colleague of mine, former colleague of mine at Hewlett Packard, who he, after leaving Hewlett Packard, got a job in Colorado and remote worked, but would spend 1 week every 5 weeks in Colorado. So he would fly there. And so effectively, remote working dramatically increased his emissions because of that. And so this is a general kind of idea. Basically, digital technology can do some good, but it also can do a lot of bad. And so if we look more generally, we can see that the same advances that allow Internet of Things, remote working, smart cities, etc., also allow more efficient extraction of tar sand in Canada, which is where this photo is taken from. This would not be possible without Internet of Things, digital technology, sensor networks, etc., to be able to efficiently extract this and make it a profit-making venture. And so as a result of this, we can say that digital technology in general, is an accelerator. It moves society faster in whatever direction it's pointing. So it's a bit like money. It's not intrinsically good or bad. It can basically accelerate society in the direction it chooses to point. And so if we choose to point in the direction of a sustainable world, then technology and innovation will accelerate us in that direction. But at the moment, the incentives are such that we do not choose to point in that way, except in minor ways. And as a result, it accelerates us in the direction of increased carbon emissions. So also drawing on what Rachel said, we must not think about only climate change. We must think about planetary boundaries more general. And John also alluded to this. So climate change is one of those planetary boundaries, but biosphere integrity, extinction rate, and also phosphorus and nitrogen flows are things which are already being exceeded. So we need to think about this holistically and think about creating a society and world where planetary boundaries come first. And that means putting appropriate measures in place to do that. And one of those things, just on the climate change, recognizing that this is not enough, one of those things is to create science-based targets, emissions reductions targets in line with the Paris Accord to allow us to reach a 1.5 degrees world, which is broadly, globally decarbonising by 2050. So every sector needs to do this, every country needs to do this, and every company needs to do this as part of what they do. And they must be kind of rigorously stuck. These targets must be rigorously stuck with. And one way of doing that is to put in place global carbon prices. This is something that exists only in piecemeal at the moment. And it's only one of the tools that's necessary, but having global carbon prices in place will mean that innovation is moved in the direction of a lower carbon world. And that's something that sometimes people argue is a bad thing. They think if we're constrained, capitalists are constrained from innovating heroically, and therefore they will not produce the innovations that they could do. But in fact, constraints are good for innovation. If you look at the Apollo program, you can see that the constraints that placed on it resulted in positive innovation. Another case study is the iPhone 3. The constraints that were placed on the designers of iPhone 3 encouraged innovation. So constraints are not bad for innovation, constraints are good for innovation. And so adopting the constraints of the planetary boundaries will stimulate innovation rather than restrict it. And finally, I wanted to say innovation is not only about technology, innovation is about practice as well. And a really good example of that is the way that we have innovated in our work life, our work practices. That we have, through COVID, we've been forced to innovate. We've found new ways of using these systems. And so thank you very much. That's what I'd like to share with you.
That's brilliant. Thanks, Chris. I mean, the idea that technology can make things worse quicker and make things better quicker. Obviously, it's been alluded to before, and I think is a fascinating question. But it also begs the question as to whether the tool begs its own function. Whether technology, if it was different, would be more inclined to bring us in one direction or another. And I think that's something that we can discuss during the panel discussion. But next up, we have Alvin Verde, who is an economist and is one of a number of our panelists who stepped in at the last minute. You can see him there speaking from the 1950s. Alvin.
Thank you, Connor. And I'm also going to share my screen. You're going to get the impression that people who work in universities can't speak without slides, and you might be right. Okay, so as Connor said, I'm an economist, and I'm going to talk a little bit about the context in which technology occurs, and I think much of what I'm going to say has actually been touched on before by the previous speakers. But I want to start by just saying that economics can sometimes disrupt some of the best laid plans, and Rachel already mentioned Jevon's paradox, and I want to start there. And the problem is that technology does things to prices. And one of the things that it does is that it tends to lower the prices of production. And that then has knock-on effects in the economy, which also then have knock-on effects on climate. And so this is a traditional economic effect, but people will tend to buy more if prices fall. And so if technology significantly increases demand in this way, it could have a counter effect on climate emissions. And you might say that, and what you've got here as a graph is just to show you that energy demand has just continued to rise despite all our efforts at climate reduction. I mean, that hides some of the kind of nuances in some countries lower down there. But by and large, energy demand is still rising. And you might say that, well, we're talking about cleaner ways to produce rather than cheaper ways to produce. And so this effect may not actually happen here. But even if prices don't fall and consumers shift to cleaner energy sources, if they can consume with less energy per unit, there may be an effect which increases their consumption anyway. And this is what we would call a behavioral response in economics. So in other words, carbon saving technology might provide a license for more consumption, which has effects on the environment in other spheres, such as congestion, water use, and land use. And so these behavioral responses might matter even if the price effects are not there. So either way, you can't really escape the kind of interrelationships between technological progress and these economic variables that I'm talking about. And on this slide here, I've just got a picture. By the way, these are from a fantastic website called Our World in Data, but just showing how carbon dioxide emissions rise with GDP or income, which is on the horizontal axis here. And so the challenge then is to lower these gradients so that over time, if growth happens, if these price effects occur and people demand more, that demand isn't associated with greater carbon dioxide emissions. And so really, in essence, we're talking about leveling or even sort of ensuring that these arrows are pointing downwards. But the challenge that technology has, if we want to do this, is that we're talking about a reduction of billions of tons of emissions per year. And my question is whether technological progress, even if it can affect this kind of change, is feasible at this kind of rate. And there was a report recently by the International Energy Agency on clean energy innovation, which kind of said they looked at 400 technologies in electrification, carbon management, hydrogen, bioenergy, but found that really only a handful of these are likely to be commercialized in any kind of realistic future over which we need to get these kinds of reductions happening. So we're saying that new technology needs to reduce carbon intensity of energy production. It needs to reduce the energy intensity of production so that continued growth, which is almost inevitable, won't have these kinds of impacts on climate. And one other issue that I just want to sort of mention here is that a lot of the world is not using the kinds of technologies that might be impacted by the developments that often we talk about. So this is just showing you a wide range of countries in the world where fossil fuels are still used for activities such as cooking. and so enormous kind of technological improvements which improve the energy efficiency of production won't impact necessarily on these countries. So one of the issues that we have to solve is global inequality, and global inequality can't really be thought about as separate from this technological requirement. So let me finish then by just pulling together some of these economic arguments that I'm trying to make here, which is that there's a complementarity between technology and economic variables, and technology exists within an economic and wider infrastructure. Development of technology, low energy substitutes, especially for things like cement and so on, and mobility, as Chris has mentioned, are absolutely critical as I see it. But addressing global inequality and access to these better technologies is going to be part of our challenge. Attention to what's happening to prices and people's behavior, the role of governments in mobilizing R&D efforts, economic policies such as taxes, Chris has already mentioned those, and of course international agreements. So I'll just conclude by saying that technology is clearly a necessary condition, I think, but it's nowhere near sufficient.
Thank you very much, Alvin. I was amazed in Ireland when the plastic bag tax was introduced, just how effective it was. The plastic bags you used to see tied to trees, they just disappeared overnight. And it wasn't as if, I mean, it's only a small example because it only required small changes in our behavior. But it wasn't as if 5 pence was likely to be a serious economic cost for many people. But somehow the opportunity to save 5 pence gave us permission to, I think, adopt a behavior that we already wanted to adapt, and bizarrely we're embarrassed to adapt until we were given permission by the idea of saving 5 pence. So I think, or 5 cent in fact, it was in Ireland. But I think, yeah, the economic conditions our behaviour surprisingly, it is extremely sensitive to economic conditions, and I think that's something that we can talk about more in the discussion. So next up we have Ruzanna Chitchyan. Where is she? There we go. Yeah, you need to change to slide presentation.
Yeah.
And
there we go.
Excellent.
Is it okay?
You're quite quiet as well. If you could move close to your microphone.
Okay.
So Ruzanna is also from our school, and like Chris, seems to have an academic profile that spans many different intersecting disciplines, but part of the unifying theme, as I understand it, is the environment. So Ruzanna, again, has stepped in at the last minute, so thank you very much, and off you go.
Thank you. So what I want to do is maybe to restate a little bit of question and say, okay, climate change, is engineering enough of climate change? But do we actually know what is engineering and what we are engineering is another question. So if I ask you what is engineering in here, maybe most of you, going back to the idea of technology, which was mentioned as a key point of engineering, would say, well, nowhere there really. But if we think about engineering as a human activity, which is brought to every kind of aspect of what we do as humans, we create, we change our environment. If we look at these two pictures, we have actually engineered these fields, we have cleared the forests. We might have engineering technology in the ship. A colleague of ours has been working on RFID tag and internet through ship. We might have actually changed the route of the stream that's running there. So engineering is everywhere. We can't think of engineering as developing technology. We are engineering everything around us. Even when people were living in caves, they were engineering the environments. So engineering underlines everything that we do. And what we really need to think about is not whether engineering is good or bad or is it enough, but how to engineer in such a way that we support the needs of humans, the needs of the environment, and also the needs of the technology itself. So really what we need to think about, how as engineers in everyday practice we integrate the concept of engineering sustainability into our environment rather than engineering tools or engineering technology. So this is a piece of work that I've been doing with colleagues for the last 5 years. And the key point in there, and I'm a software engineer, but you can replace software with any kind of engineering, civil engineering, for example, anything that you build, create, or change. How do you make sure that whatever it is that you build, create, or change, and we do this all the time, integrates the notions of sustainability into its core activities? And this is what we have not been doing, and this is what the problem is. So this is an example of Airbnb as a system that we develop as software engineers to rent out spare rooms. But what we're really saying is, up till now, we've just been developing a system as software engineers. But if we start to consider what kind of social, individual, technical, economic, and environmental impact that system has, we will likely develop a very different system. So for example, what we do is rent a room. That's a core functionality. But what does it do to individuals? It gives individuals greater earnings. We also have timelines in here, short term, medium term. In medium term, we earn better. That's great for individuals, positive impact. What does it have in economic terms? It actually increases the rent of properties, which are now not available for rent, but are just used as short-term holiday accommodations for Airbnb because they pay better. Okay, that is not so great, maybe for people who rent. But then what happens in the social aspect in the longer term? Well, we actually end up with racial segregation because the areas which were previously accessible for all those underprivileged people who could rent there are pushed out. Now they're going to have to go to somewhere else to live, and these areas are becoming more or less kind of rental areas for people who can afford to pay the rents, which are normally more kind of privileged people. So what we are putting forward in our approach as engineers is that it is our responsibility to consider the impact of the technologies that we develop in short, medium, and long term, and consider what the impact of the use of the technology is. And once we integrate that into our designs, we will be developing and engineering a very different systems than what we have now. So as Alvin and some other people have already mentioned, engineering is not sufficient, but an absolutely necessary part of addressing the climate emergency. And sustainability is a wicked problem. It's a problem that affects all parts of the society, all areas of our activities, and it impacts across time. So really what we need to take is a deeper interdisciplinary approach into engineering and consider what impact of engineering is. So the takeaway message that I would like to say is engineering is omnipresent, and whether you like it or not, you are doing engineering, even if you are not an engineer by yourself. As a policymaker, you engineer a structure within which the society will operate and develop and change itself, which is to say engineer. So engineering is a systems discipline. It's not a technology development discipline. We never develop technology, we develop socio-technical systems. And finally, engineering reflects the values that we put into it. We need to consider things like, yes, even if when we're talking about sustainability, what exactly are we going to sustain? Is it the biodiversity? Is it the human well-being? Is it the economic well-being? What? For how long? Is this for a year? Is it for 10, forever? How much is it going to cost? Are we prepared to pay? Who are we considering as relevant entities in this process of sustainability engineering? Well, biodiversity is a kind of thing that can be considered as a stakeholder in the systems that we're engineering, as can other issues to be integrated into it. So in short, what we value that we engineer. And finally, if you are interested in Manifesto for Sustainability Design, please have a look at this URL, and there is lots more there to consider. So thank you very much. That's me.
Thank you very much, Ruzanna. And we'll move on to our final panel member, Kerstin Eder. Hey, Kerstin.
Hi.
And she's going to talk to us for a few minutes before we start the discussion. So, Kerstin, thank you.
Thank you, Connor. Hi, everyone. I'm Professor of Computer Science. I lead the Trustworthy Systems Research Lab at the University of Bristol. Now, one way to gain confidence in the trustworthiness of a system is by transparency. So in the context of our discussion, I would like to focus on energy consumption of computing. Now, back in 2010, I started an initiative called Energy Aware Computing at Bristol. And I brought together experts from all layers in the system stack of computing systems, from hardware designers all the way up to application software developers. And I did this with the aim to understand how computing consumes energy and what we need to do in order to lower the energy consumption of computing. Now, in practice, most developers are, let me say, blissfully unaware of the energy consumed by the code they write. In contrast, though, low power design has been the focus for hardware developers for decades, and we all benefit from this in the technology in our mobile phones, for instance. But ultimately, it's software that controls what the hardware does. This is kind of similar to driving a car. Even a very fuel economic car can be driven in a way that consumes lots of fuel. Now, ICT is the 6th largest electricity consumer worldwide, and we've seen various graphs today. So if you were to order them by consumption, ICT would be on the 6th place in those graphs. It's consuming more than twice as much as the entire UK on its own. Now, unfortunately, despite improved energy efficiency, energy consumption through electronic devices will triple until 2030, based on a prediction that factors in massive rise in overall demand. Since 2014, there are officially more mobile devices in the world than people. So, each one of us has more than one. Now, at Bristol, we have coined the term energy transparency, and it provides energy consumption information of programs to the developer, the tool chain, and in the longer term, the end user via energy labels of apps and websites. And our research enables developers to write what I'm calling more energy efficient code. We call this cool code, if you want. And we're trying to make this available for programmers in the future. Now, to get back to our discussion, in general, it's my opinion that a techno fix won't do. We all have to take responsibility, and we need to change the way we do things. And that starts with the use of electronic devices. Thank you very much.
Brilliant. Thank you, Kerstin. That was very useful. So if the panel speakers panelists would like to switch their cameras back on, all of you, and we'll have a discussion, which, as I said, I'm very looking forward to. But again, thanks to you all for coming and speaking. I thought that presented the breadth of the problem and different viewpoints of the problem. We're all trying to help the environment, but it's hard to know what that means or what that should mean. So I'll just kick off with a question from Sarah Rogers. Oh, to remind the audience, do stick up your hands if you'd like to, electronically, if you'd like to speak, or if you want to put any questions into the Q&A, that would be brilliant. Sarah Rogers, specifically addressing John, says, a great talk. Thank you for coming to talk to us, and I think we all agree with that. Most interesting to learn about the poultry numbers, indeed. I have 2 chickens in my garden, so I feel I'm contributing to the wrong side of that. Interested to hear from you about what you think is the fastest change that will have the biggest impact we can do this year. And I think that's something maybe all the panelists have a view on. If we were to do one thing this year, what's the thing that can quickest have an effect? So, John.
Well, I mean, look, as an individual, you mean? Is that what you're implying? What individually could we do that would have the fastest, quickest impact?
Well, I'm not quite sure what Sarah means, but let's go for that.
Look, I mean, without doubt, as an individual, look, I think there are 2 things that we could do that would completely change everything. One would be if we had a plant-based diet. There was some Oxford academic that said if the whole world was vegan, and I'm not a vegan, and I'm not saying that people should be vegan, so it's just an abstract exercise, but he said if the whole world went vegan, the amount of land you could give back to nature was the equivalent of North America, Europe, China, and Australasia, right? That's how much land we use for livestock and feeding livestock. So all of the ecosystems across Latin America, in the Cerrado, the Pantanal, in the Amazon elsewhere, that are being trashed for soya, for animal feed, to feed our pigs and chickens and so on. All of that could go back to nature if we had a plant-based diet, or even a more plant-based diet. And of course, that would soak up huge amounts of carbon, really help with the climate impacts, as well as restore biodiversity and so on. So that's one thing, would be to have a more plant-based diet. And the other thing is renewable energy. You know, to what extent, you know, I don't know, you're scientists, not me, but what is it? An hour's worth of energy from the sun could power our entire global system for the year, maybe many times over. I don't know what the actual figure is, but you know, there is a plentiful supply of renewable energy if we could tap into it. And of course, it's become ever cheaper to tap into it. And I think that this is the other big issue. You know, why is China, or even India for that matter, but particularly China, still building gigawatts of new coal-fired power stations when renewable energy is actually cheaper? So, you know, there is some strange things going on here in terms of vested interests and the way we've designed our system. When you kind of think that renewable energy is cheaper, why are we not using more of it? A plant-based diet is possible to give us a really healthy, much healthier actually, diet than the one that we have at the moment, both of which would go a huge way to solving the problems that we face.
Thank you. Does anybody else have a view on that? Rachel, what's your thinking?
Yeah, I think that it's very important when we're thinking about acting as an individual that, so I'm not saying that people shouldn't move to a plant-based diet, but that individuals moving to a plant-based diet doesn't solve the problem, because the system is still set up to increase capital and increase consumption. So I think the thing that has the biggest effect is basically asking yourself the question, are you living your life as if this is an emergency in which the government and the vested powers and interests are not acting in our interests? And the answer to that question then leads you to work out what is it, what are the levers that you have that can change that the most. And for me, activism is that, but there are some other routes, and radically telling the truth and seeing how we can get the system to change. And part of that is to make your own individual changes to sort of reduce fossil fuel use and move to a plant-based diet. Because that gives you moral authority to talk to other people. But without that political change, we're lost.
Thank you. I think some other people in the panel will want to reply to this, but before we go to that, Sarah, who asked the question, would like to follow up. So Sarah, I think we'll unmute you now and you should be able to speak.
Can you hear me?
Yeah.
Thank you. Sorry. So thanks to John and Rachel for those answers. I think, yes, my question was originally based on individual actions, but then I guess the audience here at Bristol, or certainly within this conference, are engineers. So I guess taking that a level further and saying, what as engineers are the greatest thing? Grants take a long time and projects take a while to see fruition. You know, are there small step changes that you think that engineers can do? Thanks.
Ruzanna?
Yeah, that's exactly what I wanted to say from the very beginning. It is not, even if you're not engineer, it doesn't matter. We spend, well, at least 8, maybe longer hours of our day being professionals. And the best thing you can do is find out what is it that you can do as a professional. And policymakers are professionals. I mean, you know, everybody is a professional in their job. So what can you change in your job, or what can you focus on in your job that will make that difference? Well, I'm a researcher. I also do teaching. So, you know, in my kind of way, I focus on providing input into the research and the teaching activities that are focusing on sustainability and supporting sustainability. In my case, it's energy systems. Other people can do other things. It doesn't matter. But the key thing is, yes, you can change your diet. Yes, you can cut your travel. But unless you do it in your professional capacity as well, the system, as Rachel is saying, will not change. So the best thing that you can do is focus as a professional on your activities and review and try and make sure that everything you do as a professional, because that's in the end going to be the thing that you're going to put out in the world. Everything that you're putting out in the world, is it making things better? Is it cutting, reducing, reusing, you know, all those things.
Thank you. Sorry, Alvin, I wanted to ask a version of that question to you as an economist. John and Rachel have both mentioned that the first thing we could do is give up eating meat. But of course, there are people who won't want to do that, or whose way of life revolves around eating meat. And it seems to me what's important is that if you do want to eat meat, that you have to compensate the rest of us for the environmental consequences. That a lot of the environmental problems that we have are that we aren't able to fully price in the true cost of things. For example, when you are driving around the streets, you don't have to pay me for the inconvenience I suffer from having your cars whizzing past me and preventing my children from playing too near the curb. And so, do you think it's possible that these choices, these good choices, could become part of an economic system where those who do eat meat will eat meat, but they'll pay the rest of us for the fact that they're causing 70% of birds to be chickens?
Yeah, it's a very, very good version of the question, Conor. And my first response actually when you first asked the question was that the one thing to do would be not just to do one thing. You have to do lots of things, and it made me think of people who take out subscriptions to gyms and then go for once or twice and then never go again. And so there's an issue here about the sustainability of the changes that we make, and we make these changes in a kind of, as you're describing, a kind of economic and legal system, and so what we really need to do is to sort of make sure that the changes that people are making, that the incentives are there for people to sustain those changes over a long time. And you've picked up on a really important issue, which is that one of the really important problems here is that most of the ill effects of the actions that we take are externalities on other people, so we don't see them ourselves in any big way, and they're sort of in the future, and they're imposed on other people. And there's a very big free rider problem, which is that you just hope everyone else will become a vegetarian and you can carry on eating meat. And I think my sense of this is that the way to solve this problem is to ensure that the incentive structures are changed so that people make the right decisions, and that does involve the legal context and the taxation context to alter prices in a certain way so that these choices are easier for people to make. I mean, you mentioned plastic bags. I mean, none of these go far enough to solve a systemic problem, but in the end, this is all an issue to do with billions of very, very small decisions that are made on a day-to-day basis on people who are responding to their kind of environments and prices and markets around them.
Thank you. That leads to another question that we've had in the Q&A, which is from Kieran Nadu, and he addresses it in the first instance to John as well, but I think, as is pointed out, this is a question that everybody might have an opinion on. They say, it seems that areas like Southeast Asia are still lagging behind in terms of regulation and conservation, which is causing a greater risk of deforestation. If governments aren't prioritizing the climate, it is much more difficult for society to shift their mindset and start thinking in a more sustainable way, especially in research and development. Keeping in mind that governments don't seem to value this, what are some ways that areas could start moving forward? So, John, do you have a view on that? How do we, well, I mean, you must have a view on that. How do we get governments to change their minds? Or what do we do if they want?
I mean, partly this comes about through political pressure. But I think that in terms of where governments are at, I mean, we've come a long way since the Paris Agreement, where I think every single country in the world signed up to the Paris Agreement. Every single country agreed that they were going to put a plan on the table as to how they were going to deal with climate change, and increasingly large number of them have now got commitments to go to net zero by 2050 or 2060. I think it's also worth kind of thinking about the fact that, look, nearly half the world's emissions come from two countries, China and the US. If you take the G20, you're taking out about 80–90% of the emissions. So actually, the number of countries that are actually responsible for climate change and biodiversity loss is relatively small. There was another study, I think the IMF or World Bank did, that said 189 corporations were responsible for about 85% of the world's emissions. It is a relatively small number of corporations that are overwhelmingly responsible for the problems that we face. But I think that's where, you know, the really difficult problems come, because of course these corporations are immensely powerful and influential, and the governments obviously are also immensely powerful and influential as well. So, you know, that does mean at the end of the day that we have to put very intense political pressure on these governments and these corporations. And, you know, to a certain extent, you know, public opinion is really important and is having an impact. As citizens, I think also as consumers, we can also have an impact in terms of the choices that we make. And I think that, you know, but ultimately that does come back to the things that I said at the beginning. You know, there are some technical fixes that as engineers and others that we can do to make this change relatively easy for people. And there are other things that require behavior change. And it's in that area that it is more complex and more difficult. But certainly, if, for example, as we just discussed, the externalized costs were put onto the price of the product, that would make a very big difference. And I think there are lots of studies that have been done, for example, with food, where for every pound you spend on food, there's a pound of externalized costs that you don't pay for. But ultimately, we do pay for them because we pay for them in our tax, in our NHS, in poor health, in shortened life expectancy and biodiversity loss, and so on and so forth. And I think it's that we have to make that much more transparent and clear in terms of who's paying, who is suffering the impacts of this, and making this whole system a lot fairer and more just than what is happening at the moment.
Thank you. So, Kerstin, I think you were going to speak earlier. Do you have a comment?
Just to echo this, I think it's really important that, you know, there's various things we can do. There's political pressure, doing the right thing yourself, voting with your feet, but also taking part. You know, there are local sustainability things that you can do, and the transparency is a really critical thing. That doesn't just apply to the energy consumption of computing, but if you're aware of how much things cost, not just in terms of money, but what it means, you know, how much is consumed in the process of production, and etc. This transparency will provide a moral ground for people to make the right choice, I think. And I don't think we have sufficient transparency. It is not possible. It's often very hard to, you know, it takes effort from you to turn a product around and say, where has it been made? Where did it come from? Do I buy local or do I buy shipped in or so? But if we all sort of change behavior on those lines, then government should eventually get the message that we want something different.
So, Rachel, in your talk at the start, you referred to the obligation on engineers to become radical truth tellers. Is this what you had in mind? Kerstin's advocacy for transparency, that part of the role of an engineer is to make sure that we know what's happening and what it costs?
Well, I think transparency is important, but I mean, simply just having the transparency can lead to some changes happening, but it's really hard if you've got to make a choice on every single item that you buy in the supermarket as to what exactly has gone into it and all the ethical considerations. So it's much easier if the system has changed so that we know that everything's going to be low carbon. So I think what I'm saying is we have to move towards that. We need to use certainly our truth-telling voices to say, hey, look at how awful this system is, because this is what the real cost of a mobile phone is, or this is what the real cost of these things are. But yeah, I don't want people to feel like they have to individually be making those choices on every single thing. What we need is to be demanding that the system changes. Yeah, so does that make sense? And it's not just about sort of what we're doing at work, although I know that that's important and I don't want to stop people doing that, but the pressure has to be on the government, on the legal, the economic system to make those changes so that then the engineering solutions that we provide can be useful.
Thank you, that's very clear. Ruzanna.
So I have definitely, I mean, I agree that as individuals, we look, so change has to happen everywhere, in personal life and in professional life. So I do still underline that most impact we make is in our professional life, because we put things out there that other people then rely on, especially as engineers, right? I can write that code which is energy hungry, or I can write that code which is energy efficient. I can build that building which is well insulated, or I can build that building which is leaking all the heat. And then you have to live with it, because that's what you get from me as an engineer. So I do underline that as engineers, professionally, we put things out there that then other people, other businesses use. And we need to take responsibility about what it is that we're putting out there. So that's the first thing. But secondly, the system is not made out of some fuzzy things. We vote for that system and we are part of that system. As engineers, we're part of engineering professional bodies. We have standards that we agree upon. We have bodies which regulate and make sure that our things are acceptable or not. So again, as professionals, we can have an impact about what is acceptable output from an engineering activity. Is it okay for you to generate something which is going to be energy hungry code, or it's not, it's only going to be acceptable if it meets particular standards? So standards bodies is something that we define ourselves again as a body of the profession. As software engineering professions, we have, for example, software engineering body of knowledge. Why on earth does software engineering body of knowledge not stipulate that as a software engineer, you are responsible for things like energy impact of your software that you develop? Or, you know, all those things are things that we can do as professionals and we need to do better.
Thank you. So Chris, I mean, related to this, I think it's the question that I have after your talk, which is that you spoke about technology as if it had no direction, that it could be, it was the servant of society. But it always strikes me that the technology we have, as I said, begs a function. Can we change the technology we produce in a way that draws on itself a more sustainable use?
Well, I think I would say yes, we can, but going back to what Alvin was saying and others, only if the system encourages it. And so the shape of the system in which we innovate is what drives the direction of that innovation. There will be exceptions, there will be, but generally you're kind of locked into a certain regime, a socio-technical regime which determines the direction of the innovation. And there will be pockets of experimentation, but they will only be picked up if the incentives are in place. A really good example of that is renewable energy, which really struggled because the regime was so against it in the 70s. You know, we could have made far more progress in the 70s and the 80s if the regime hadn't been so both passively and actively resistant to the deployment of renewable energy. That's I think that basically, yes, it is possible, but changing the system, and I think I would agree with Ruzanna, what Ruzanna was saying, is that the engineers can also be part of the conversations about how the system needs to be changed to do that. And kind of building on what Rachel was saying, I think that there are, so if you are a activist, there are two tracks. There's the outside, what's called the outside track, which Extinction Rebellion epitomizes perfectly, which is where you go on the streets and lobby and shout and make people aware. But there's also what's called the inside track, where you engage in conversations with people who have authority and power and help them find ways through, because many of these people are not necessarily kind of evil demons who are only interested in filling their bank account. They're subject to the pressures that are on them that kind of shape their behavior, their activities, and helping them find a way through, helping them find a way to move the power that they have. And it means working with corporates, because corporates are where most of the power is in the world these days, helping them find a way to move and advocate for different versions of the system. And to be honest, in the last 2 years, there's been a lot of that going on, partly in response to activists like Rachel. It's partly in response to activists like Rachel on the streets that conversations take place in the boardroom, between politicians, etc., and progress is being made. But the power, it needs to come from both outside the system and from those people of goodwill inside the system. And I think it's important for engineers who have that technical knowledge to contribute to helping those inside the system who have goodwill, want to find ways forward, to work out how the system needs to change. And again, Ruzanna's spoken to that also, I would say.
Thank you. John, have you found that in the last 2 years there's been a change, that your message is being better received, that you're able to talk to corporations in a way that you couldn't before?
Yeah, I mean, absolutely. I mean, we've run a campaign, for example, against oil corporations for several decades, and including, quite high-profile campaigns to stop them opening up new oil frontiers in places like the Arctic. And I suppose it was quite a dramatic change when the new CEO of BP, Bernard Looney, agreed to cut oil and gas production by 40% by 2030, and to increase the renewable energy in his portfolio from 2 gigawatts to 50 gigawatts. And he actually came to my office in London to discuss these changes that he wanted to bring about. Now, I've never had the CEO of, I've been to their offices, but I've never had the CEO of a big oil corporation turn up at my office. So, I think that was in a way, that was kind of a shift that was happening, that these corporations, it was partly external pressure, partly regulation, partly shareholder pressure, but they were also finding it difficult to attract young people. Students from Bristol University didn't want to go and work for a big bad oil corporation causing climate change. So, I think that they're facing multiple pressures. But I think it's also interesting, the example of the solar panel is interesting. The first solar panel, I think, haven't really looked into it, was designed by Philips in 1956 from memory, when I read something about that. It'd be really interesting for someone to look at the development of the solar panel from when it was first produced by a company back in the 1950s to when it actually dropped dramatically in price and became commercially viable, first by Germany and then by China take it into mass production. That took nearly 50 years. Now you imagine in those 50 years, trillions, tens of trillions of dollars went into fossil fuel development. Imagine if in the 50s that, and even a small fraction of that had gone into solar panel production, the world would look very, very different today. Why were those choices made? Who made them? Why was one system, the inertia and the status quo held onto so strongly by one set of corporations against another? Because Philips is not a small corporation, but the whole politics around that and what actually happened and why it went on for so long. I think that is an interesting thing to look at in relation just to one technology. What happened to the solar panel? I don't think I've ever seen or read a study about that, but I think that would be a kind of an interesting thing to show the politics, the power, the influence, the corruption, and everything else that goes alongside this discussion about technologies which win out, how do they win out, and what are the complexities in making sure that the green technologies win out. But sure, I've definitely seen in the last couple of years, it has been a dramatic shift, and there have been some very interesting innovators who have caused a lot of disruption to the status quo.
Oh yeah, I mean that's a really interesting topic. You know, at some point we're going to have to move to renewable energy. It's such a pity that we're doing it at this late stage, when if it had been done earlier, things would be so much better. Kez, Kez, I see your question, and I'll come back to it in a second. But first of all, Alvin, I think this again comes back to the sort of thing you've been talking about. David Birdi asks, what do you think about a red, amber, and green system on groceries and products in supermarkets in relation to environmental impact? Would this be possible, and what are the failings of such a system?
So these kinds of things have been used more in terms of sugar consumption and diets, really, rather than. But there are labeling systems like the MSC badges for sustainable fishing and so on that can be really effective. I mean, you know, the kind of impetus for this is to increase transparency and information so that you increase the sort of efficiency of the choices that people make. And my worry about it is, well, there's a number of worries really. One is if in this environmental sort of area, how would you make it? How would you know? I'm not sure what the red, amber, and green would be. Red, you know, what sort of scale of environmental damage they would need to cause in order to get a red badge, and also, I'm not sure, you know, what would we do if we had a kind of labeling system which had red, amber, and green, and everyone chose the red stuff? You know, we turn around and say, well, that's absolutely fine because people are making choices. And at some point, you know, information and market efficiency has to come into conversation with the kind of ethical and imperatives which underlie this agenda for kind of climate change reduction and climate emission reduction. And so there might be, you know, we probably need to think beyond consumer sovereignty and information and efficiency of markets to the kinds of things that we were sort of sketching out, that you know, there may need to be a more regulation of commodities, for example, rather than because the thing I'll just finish on is, you know, information is very good and can work really well in this area, but you are then kind of presupposing that people have the education and ability to make the decisions given the information that you've provided them. And so it does beg the question, you know, doing that on its own is only going to work if people understand what the red means, and that's an educational problem.
Thank you. So this is a kind of a follow-on question. As computer scientists, you know, one of our great mottos is always never optimize outside the inner loop. You always try not to make something fast that isn't actually slowing down your program. And James Foster, I think, is suggesting that that we have to act much more radically and change our whole economic system to do that. And so I was wondering if Rachel could give some thoughts on that, since she both well, is an environmental activist and comes from a computer science / mathematics background. So James Foster, just to actually quote his question specifically, we've talked about incentives and consumer behavior, but the fundamental incentive that drives us to, that has driven us to this point, is the incentive of profit. How can we create a sustainable society without eliminating this fundamental wasteful motivation? In software engineering terms, this is what I referred to, when we want to increase efficiency, we don't focus on small optimizations, we focus on the core cost centers, and profit is that center which drives everything else.
Sorry, I got slightly confused at the question because the question's disappeared from. Can you?
It's in the section called answered. It's the very, although it hasn't been. It's in the. So if you click on answered, but
my fault. I did type. I thought it would be just my kind of thing, but it just removed it completely.
That's fine. So the question.
Yes.
Yeah, go on.
No, you go ahead. Go. Give me a.
The question is it enough to talk about these small consumer changes, etc., or do we need to fundamentally remove profit as a motivator in society? Do we have to abandon?
Yeah, I mean, I think for me, looking at it as a logician, it's when you start sort of just looking at the individual changes. it seems to me that you want to start at the other end, really, of saying, looking at the carbon budget that you've got and then making sure that you keep within that carbon budget in a way that, in that holistic way that we've been talking about all session. So it makes much more sense. And I think that is quite similar to that software engineering idea of finding out where your program is actually spending the time before you start doing the optimizations, is actually go to the root of the problem. And I think there are a number of tools that you can use to help with that, from the carbon taxes and increasing, but in the end, we've got to change the legal system. We've got to change the way that we think about things, the way that society functions. I think it is going to have to fundamentally change. And I think sort of playing into some of this, I mean, Extinction Rebellion's ideas, we haven't really talked about this, of citizens' assemblies are, the things that they're talking about there are ideas around participatory democracy. So the idea is that you're getting people to make the decisions, so that the way that you remove the profit from driving the system is to get citizens involved in the democracy, so that the things that they value can be taken into account. And I'd quite like to hear what Chris has to say on some of this, because I can see he's raising his hand there, and I suspect he'll have a very good point on it.
Chris.
Yeah, so I mean, I to a certain extent, John said something about this right at the very beginning, and we also. So I think one of it probably is too late for us to try to solve climate change by getting humanity to give up the profit motive. We can't change the system that quickly, and when we trying to change the system radically, we have no idea where it's going to end up. So I certainly think that we need to harness the profit motive to some extent. But I completely also agree with what Rachel's saying. It must be done in as democratic way as possible. We need to restructure the system so that corporations are rewarded for behavior which is more in line with planetary and human values. And that doesn't mean getting rid of the profit motive, but it means that putting in structures which shape the engagement of corporations in those directions. That's my feeling. In the longer term, I personally appreciate being more in touch with nature, etc. But I don't feel I can force that on everyone in the world in time to change the way we do. But more democracy and restructuring the financial system. And I think that is already beginning to happen.
So Ruzanna, we're heading towards the end now, but if you have a quick comment.
Yeah, actually, to disclose to kind of everybody, I come from ex-Soviet Union, and we tried to get rid of profit, and it didn't work out very well. Not because the idea is not good, the idea is excellent. It's just that you need to have a level of thinking across the whole population that needs to be doing and working and contributing to the most of their capacity without expecting anything extra in return. So, and simply people are not ready for this. Maybe in a couple of 100 years, I don't know. The idea is great, but it just doesn't work because people's mentality is not there. That's the first point. And the second point is, probably Alvin should be saying this, but again, I have an economics degree as well. So the thing is that profit is a payment for taking on risk to do some activities. So if you don't reward the risk, at the current level of thinking of people are, why would I take the risk? I'm not getting anything back anyway. So profit is also a motivator for action. And in this case, if it's an action to do something which is risky, to make a new, a change in technology, in the way that your business is run, which is for sustainability, that's not a bad thing. So in either case, it's not the point of profit, but what the profit is coming from, and whether or not all the costs and externalities are accounted for in making that profit count.
Thank you. And Kerstin, I wondered if you had a view on this?
There's an interesting observation, the removal of profit from a society, and I agree that people aren't ready for this. It's a great idea, but I've also grown up in a system where there wasn't any official profit as such, and looking at that, it was much more sustainable. There was no plastic bags; everything was in paper bags, and you would take a shopping bag when you wanted to go shopping. Otherwise, there was no way of doing it. So there are ways of doing this that have been tried and trusted, and bringing bottles to shops when you want to, take something home. That's what we did. and when you go into one of these shops and say, yeah, I grew up like this, and as a kid I did that, they look at you really strange and say, where do you come from? It's not that long ago that this worked. And okay, the system itself wasn't sustainable because it had other flaws, but that sort of thing should really be looked at. So that we can make a step in the right direction with confidence that that part of the system works. And I agree, it's a systemic change that is in the system, but also in people's mind. And I think looking at my kids, the education system is doing a reasonably good job at this. The next generation is much more switched on and looking into what they want to study, how they use resources, and I'm impressed how this generation is taking active part in making a change, and they are voting with their feet, right? They're not afraid; they're voting with their feet, and I think that's a good thing. Watch that space. The young people are very, very proactive.
On that upbeat note, I'm aware that we do still have some questions in the Q&A, but we'll get maybe we'll get. Some text, sorry, I'm saying that very badly. Somebody will type a quick answer to those. We're already a little bit over time, so I would like to wind up now. I think that was everything I hoped it would be. It was really amazing to hear all those different expert views. I want to particularly thank our external guests, John and Rachel. It's great. It's really great that you came to talk to us. It's very good of you to come and talk to us. It's great that you do what you do, advocating for sustainability, for the climate, and generally for the ecosystem. Also, thanks to the rest of our speakers, and in particular Alvin, Kerstin, and Ruzanna, who I asked at the very last minute. It's a pity that Phil wasn't able to join us, and perhaps we'll be able to discuss this with him at some other time. So I hope you all enjoyed the research conference. I think it's been a great success. Next year, hopefully, we'll be able to meet and do this in person. But I do think it worked very nicely like this again. Again, to repeat my thanks to everybody who's helped, and thank you all very much. Goodbye.